Hello! If you are a regular viewer of my videos, you'll notice there's something a little bit different about me. And in fact, if you're wondering, yes, this is a PHP video. But in my previous video, we talked about abstraction of your database credentials when connecting with PDO. But between you and I, do you think, you can tell me, do you think it was just a tinsy winsy little bit too easy for you? Well, of course it was. Are you ready for me to stretch your mind a little bit more? Of course you are. So today I welcome you to SQLCraft. Look at that, it's glorious and is in no way a ripoff of Minecraft. I mean, obviously, this is Minecraft, but we're just gonna call it SQLCraft. Now, there is a reason why we are in Minecraft, because I want you to think about SQL and PHP, in fact, because look, it's PHP. Yeah, I want you to think about SQL and PHP as if they're blocks. Now, if I go outside again, imagine that your PHP class is this huge block, if you can see that, okay? So what we want to think about PHP classes is a big block of code which has inside it other blocks of code. Look at this beautiful, it definitely in no way took me 6 hours to make this, beautiful blocks of code inside a much bigger piece of code. And then inside that we have other blocks of code. And I want you to think about SQL and PHP, in fact, as blocks. And I'm going to demonstrate that in this next animation. Okay, so let's have a look at the select statement, which we break down into much smaller blocks, which represent the SQL select, for example. These will be SQL blocks. And within each of those SQL blocks, there's going to be an array of fragments. These are fragments of code, fragments of SQL, which represent the SQL string itself and the parameters that go with that string for our parameterized queries. Okay, so what's the point, Jeff? What is the point of breaking down simple SQL into this overly complex structural understanding? Well, we want to create an object-oriented way of building out SQL. But why don't we just plug a load of SQL into PDO directly? Well, there are several reasons why we don't want to do that. Number one, writing out SQL queries is generally quite repetitive. You'll often have very similar queries in various places around your code representing the same database table. And we can solve that repetitiveness by building dedicated query objects. Number two, writing SQL isn't always straightforward. We're often faced with constructing SQL within logic that makes string concatenation and parameter array building a little bit tricky. And assuming we want to stick with parameterized queries, which we do, then we need an easier method of doing it. Number three, this stuff is pretty cool. And if you take the time to understand it, you'll also be cool, but in a kind of only extremely geeky way. There are many existing and popular SQL Builder libraries out there, but as usual, the point here is to expand our understanding of PHP and to develop our programming skills in general. So let's get into some actual code, which I will be making available on GitHub. Let's have a look at what we're going to be building. This is roughly the structure we want for our code, a statement containing blocks containing fragments. We're going to start with building the SQL fragments first, because their sole responsibility is to maintain the association of 0 or more parameters for our parameterized queries with a fragment of SQL code. That seems like the logical place to start. Okay, so this is the first look at our SQL fragment. I've created a new namespace in our PHPnuts project database SQL. So in my folder structure, which might be a bit small, I've got a database folder, a SQL folder, and then inside that I've got a SQL fragment. Now, our SQL fragment is literally just going to be a SQL string. So it's going to have a string with which we're just going to call SQL. And the second, or the only other part that we really need, is an array of parameters. Next, we're going to create the construct. Okay, I'll just paste it in. Initially, we're simply going to map our inbound SQL and parameters arguments, which is this one and this one, onto their respective private properties. So SQL and parameters here. Okay, now I've purposely allowed the parameters argument not to be strictly typed as an array. So here, although we're defining it as an array, we're not here. And I'm doing that so that we can accept single parameters more conveniently. But to do that, I do need to add some additional checks, and that would look, let me just copy paste it in, something like this. Now this means, this block here, whoops, means that if this parameters array is expected to be an array, but if it's not an array, that it is a scalar or a null value, then we're happy, and we'll rewrite the parameters argument into an array. So we're just saying that's a single parameter. So it should be an array, but it's just singular. If for everything else, then it's an invalid argument, and we just throw an invalid argument exception. Next, I want to expose read access to both our internal SQL string and our parameters array. So we'll do parameters first because that's alphabetical. So get parameters. And the second one is our get SQL. Alrighty, cool. Now that we have a basic object, we can create a test for it, particularly to ensure that our single parameter logic is functioning as we expect it to. So I've already created a fragment test up here, which is in my tests folder. And I'm just going to add in a basic fragment. Now here I'm just saying id equals question mark with a parameter of 1. Our fragment doesn't care the syntax, the format, or anything about the SQL. It just literally is a string with maybe a parameter in it. That's all we care about. Now we're adding in a singular numeric or a scalar value, so we expect that the parameters should be converted. Now, so if I run this, sorry, I need to do an assert first. Now, we're going to assert that when we get the SQL, it's going to look the same as when we entered it. That's all we're doing. And we run our test is successful, and we're happy. Now, what that means is we assume that that's now been converted into an array. So I can test that just by saying we expect a count of 1 in our parameters, which works. An annoyance that many developers have with parameterized queries is that debugging your code, and if your queries in fact, can be a bit of a pain because your parameter values are separated from your SQL string. So you have to read through them, figure out where each parameter is in your query. So one thing that we might like to do at this point is to create an approximation of what the database will receive. And we can do that by creating a toDebug String method. And this is going to help us visualize what the actual SQL looks like. Okay, so back in the SQL fragment class, I'm going to add a new method, which is the toDebug String. Now, take a note, this method is purely for debugging. You should never use it directly with the database. It's just for us to see what we're doing. And within this method, what we're going to do is we're going to use a preg_replace callback, which is going to look like this. Okay, so what's happening here is I'm using preg_replace callback with a regular expression, which is going to find each instance of our question mark. And then I'm going to extract the first element of our parameter list and return it. and then I'm just going to output it as a string. Now, obviously, this just assumes that all parameters are a string. So I can improve that a little bit by checking for type. So I can say if the parameter is numeric and it's an integer, then we'll return the parameter without any quotes around it. If the parameter is null, then we'll just return a null string without any quotes around it. And otherwise, we're just going to treat everything as a string. So that's going to help us visualize it. So now we go back into our test and we can create a new public function test debug string. I'm literally just going to copy this, and then I'm going to say this assert equals, wow, I can't spell, equals, now it should be id equals 1 when we do fragment to debug string. So let's just test that. Beautiful. Okay, so if we were to output this as a string, this is what we would get. Rather than returning the question mark, it's returning the actual SQL as it helps us to debug it, basically. Now, some of you may have spotted a little bit of an issue. What happens if we were using named parameters? Because if we go back into SQL Fragment, we're only really taking care of question marks. Okay, so what happens if we're using named parameters? Well, I'm glad you spotted that and brought it up, because there are two potential issues with using named parameters within the context of this particular way of building SQL. Number one, there is a small chance of introducing naming conflicts. By that, I mean one part of your logic might be using the same named parameter or the name of parameter for a different parameter value. So we want to eliminate that issue. And the second issue is that you can't use named parameters with MySQLi. So that's something else that we can actually address. And to address both of those issues, I created something called a SQL parameter modifier class, whose sole responsibility is to normalize parameters fed in to our SQL fragment. And it also gives us some handy little other features as well. So I'm going to show you what it looks like. Here it is. Oops, here it is. SQL parameter modifier. And I'm not going to go into too much detail, but we'll just do a run through. So first of all, it's going to accept SQL. That is the SQL, a bit like we handed into SQL fragment. Then we break down our parameters into named parameters and query parameters. And then eventually those will be turned into parameters. Okay, so our construct is essentially accepting exactly the same as our SQL fragment. It is SQL and parameters. Then it's immediately going to go away and modify our SQL. Okay, so modify SQL basically splits out our parameters. Now I'll go into split parameters, and it's going to take all of our parameters, so we're resetting our parameters that we want eventually, and we're going to start consuming our parameters and start putting them into whether they are integers or whether they are named parameters. So i.e. whether they're query parameters or named parameters. So that's all that bit does. Okay, so once it's split out the parameters, we are doing another preg replace callback, but this time we're using some insane regular expression. Now, again, I won't go into too much detail, but basically it's looking for question marks, named parameters, and also things that look like named parameters but in strings. That's basically what all this is doing. Now, it might not be 100% accurate actually, but yeah, it's good enough. So then we iterate through each of these, and essentially it's going to do a whole load of operations determining whether we're using a name parameter, a query parameter, whether the parameter we encounter is in fact an array. If it is an array, then we're basically going to return a array-filled query parameter, which is basically question marks separated by commas. And then we're going to put that in a group. And I'll show you how that works. Luckily, that is going to be super easy to do. All we need to do is go into our SQL fragment class and go up to our construct right here. And we're just going to instantiate our modifier equals new SQL parameter modifier. We're going to accept the parameters that were given to us, so the supplied parameters and the supplied SQL. Then we're going to change this to get the SQL that's modified and the parameters that are modified. So that's that. And then we can test it out. So let's go into our SQL fragment test and give our named parameters a try. So we're going to do a public function test named parameter. All right, let's just grab the same thing here. All right, and we're going to change this to ID. Change this to ID. All right, and copy this. And hopefully, fingers crossed, it should work. Hey, it does. So if we were to, in fact, if we were to assert what the getSQL looks like, it will have changed. It will have mutated, it been modified to, in fact, that test has just worked. So what I've done is I've just tested that this named parameter has been converted into a query parameter, which makes our SQL fragments MySQLi compatible, even if we're using named parameters. One last thing before we move on to the SQL block class. Let's just take a look to see what happens if we were to use an array. So I'm just going to create a new test, function test named array, let's say. It doesn't have to be named, but what I'm going to do is just say something like if ID in, then make this an array. All right, so now we've got an associative key, and the ID is the named parameter, and that is pointing to an array of values. What we want to see is something like this. So if we were to debug string, it should look something like this, which it does. Okay, cool. So what we're doing, what's happening here is our debug string is what actually is happening is our SQL modifier is saying that this ID, this named parameter, is recognized in our SQL string, but contains an array. And that array is being converted into query parameters, which, when we do our debug string, is converted into numbers from the original parameters and is putting them into a group. So this is a really handy little tool for when we're building conditions. Okay, so that's SQL fragment done. Now we can move on to tackle SQL block. SQL blocks only really have two parts to them. First part is an array of fragments, and the second part is a string separator, which will separate each fragment in our array. And by default, in my construct at the moment, I've made my separator a new line. It could be a space. It kind of doesn't really matter at the moment. And then obviously we're just going to assign our separator to our private property and create an empty fragments array. Since our fragments are a private property, we need to be able to expose an add fragment method, which simply adds a new fragment to the end of our internal fragments array. And that will look something like this. So we've got an add fragment method, which accepts a SQL fragment and then just adds it onto the end of the array and returns itself. This will allow method chaining. We're not too worried about that at the moment, though. The next thing we'll need to be able to do is to be able to get our list of fragments. So essentially that will just be returning the private property. And we also need to be able to return the separator. So that will look something like that. Okay, so that's the basics, but in its current form, SQL block is not particularly useful. We need to be able to get the combined SQL and the combined parameters from our internal fragments. So firstly, let's add a get parameters method, which will look something like this. So essentially we are iterating across all of our fragments and merging its parameters into a parameters array. Now at this point we can do a safe merge because when the parameters come out of each fragment, they won't be an associative array. They will be just a numeric indexed. So we can safely do an array merge. The next thing to do will be the get SQL, which essentially does exactly the same thing, which will look something like this. And instead of doing an array merge, we just do an implode by using the separator. This is the method that we added earlier. And it was just going through each fragment and getting the SQL and then just joining that SQL together using our separator. Lastly, for now, we're going to add in the same debug string, which is essentially going to repeat what SQL fragment does. So we're just basically going to take get SQL and get parameters, whack them into a SQL fragment. Rather than us having to rebuild the debug string, we're just going to reutilize SQL fragment. And that's going to help us output a debug string for this block. And that is pretty much it for SQL block. It's quite a basic PHP class. Although we're going to be extending it later, the base class is pretty simple. And we can move on now to the SQL statement class. One thing is for sure, we don't just want to build a select statement object. We'll be wanting an update, an insert, and a delete statement. So we're going to create an abstract base foundation. So an abstract statement, which we've, which is here. Sorry, I lost my mouse for a moment there. I didn't know where it went. Okay, so inside our abstract statement, we're just going to have one property, and that is it. It's just going to have an array of SQL blocks. And essentially, this statement is a SQL block manager. That's all it does. Management of blocks is done by an associative key, the name. And the name will be something like from, where, limit, order by, something like that. So that means our internal array of SQL blocks, which is this array here, is in fact going to be an associative array. And setting the blocks required for a statement should be protected. So an extending class should only be allowed to add blocks. And adding blocks will look something like this. So it'll be protected function set block with a name. So this will be something like where, and then we'll have a SQL block associated with our where statement. I'm also going to add a set blocks method, which will allow us to add multiple blocks or an array of blocks in one go. I'm just going to quickly utilize this setBlocks method in a new construct. So the abstract statement, which must be extended because it is abstract, our extending classes, we want them to provide us with a list of SQL blocks, which will be an associative array of blocks. Now that we can set blocks, we want to be able to get blocks and also have various utility methods that help us manage both blocks and their fragments. So an important utility method will be determining if a block even exists. So I'm going to call that hasBlock. And I'm just going to add that under here. So this simply just says, does the name we provided for hasBlock, does that exist in our list of blocks? Now that we have a hasBlock method, we can add a getBlock method, which should let us know if we mistakenly try to get a block that doesn't exist. So to do that, I'm going to add a method in here, which when I get a block with a given name, we do a check to make sure that that block exists. And if it doesn't, we just throw an invalid argument exception, just saying, sorry, not found. The next thing to deal with is the priority of SQL blocks. So in a select statement, we're going to break it down into 8 blocks. So we're going to say we're going to have a priority of select, from, join, where, group by, having, order by, and limit. I think that's right. Okay. But I'm going to make a method to provide us with a getBlock sequence. So this getBlock sequence, which you can't really see because it's grayed out, we're not using it yet, is going to be an abstract method because we want our child classes to tell this parent class what that sequence is. And then we're going to use that block sequence in the next 2 methods, which we set up both in SQL block and SQL fragment, which is we need to be able to get the parameters and the SQL for this object. Otherwise, it's kind of pointless, right? So the first one to do, as always, is the get parameters. I'm going to put that just here. So this is where it comes into play. So for each get block sequence, block name as block name, if it doesn't have if we don't have this block, then we just ignore this. We continue because we just don't have anything to deal with. If the block has fragments, now that's a funny story because I added that when you weren't looking. So I added a has fragments method to our SQL block. Okay, I'll go back. Sorry about that. So if we don't have any fragments, we just continue. We skip this block. If we do, we've got the block and it has fragments, then we just array merge the block's parameters into a list of parameters. Again, we can safely do array merge because it will be a 0 indexed array, not an associative one. And then we just return those parameters. And a similar story is true for getting the SQL. What have I done here? All right, yeah. Okay, so get SQL will be similar. We get the block sequence, do the same check. We append the current block and get its SQL onto a SQL array of strings. So this should be returning a string. And then we implode or we join that SQL array based on a new line. So in this case, I'm kind of hard coding this. I really don't care. I think a new line just makes the blocks look nice. I almost forgot. We also want to add in our Debug String. So I shall add that down here. So once again, we got our important never ever use this in a database message because you shouldn't. Once again, we're using SQL fragment to get the SQL and the parameters into the correct order to utilize its built-in debug string functionality. And then we just output that string. Okay, now we can look at the select statement itself, and this is where it starts falling into place. And if you have been struggling a little bit to see where things fit in, then hopefully this is where you think to yourself, that's that moment. Hopefully this is it, right? Okay, so what did we say we were going to have? We were going to have our select statement extend the parent abstract statement. And within this, we're going to have a select. This will be a new SQL block. It won't be exactly. We're going to extend this further later. And we want from new SQL block. It's not going to be again, but I'm just trying to demonstrate it, and so on and so forth, right? So, and then we need to return essentially in our get block sequence the same array. So it'll be something like this. Oops. All right. Now, rather than make you sit and watch me build out a whole load of SQL blocks, I think it's just going to be easier in a montage. Yeah, let's just cue the montage.
Here we go now.
Okay, that was good. I mean, did you see how fast I was typing there? I'm pretty whacked, I have to tell you. Gosh. Anyway, our select statement seems to be done, and I've also managed to do a delete statement and an update statement and an insert statement. Now, in each of these, we're utilizing traits so that we can share common functionality between, say, select. So select has a from trait, which is also being used by delete. And we're also using a join trait, which is used by delete and update, and where trait, which is being used, oh my God, by the delete and update. And going back into the select statement, you can see that we're also using some other traits, order by trait and limit traits too. So order by and limit trait. And if you've not used traits before, the best way I can describe them is it's a kind of a mix-in solution to the lack of multi-inheritance in PHP. That means that classes in PHP can't inherit from more than one class, but traits allow you to mix in functionality, which you can extend, in fact, in the child class. And it's kind of PHP's answer to multi-inheritance in a way, I guess. Anyway, regardless, the end result is that we can share common code only in the classes that apply without having to duplicate our code. And each trait in this solution is quite simple. So if we take a look at the where trait, for example, I just did a control click there to get into the where trait. We can see that we've got an and where, an or where, and just a straightforward where method, which is basically being injected into our select statement. Okay, so if we go down the script a little bit to our construct, we can see that I have replaced what was there before with constants, so SQL keyword constants, which I've basically written, and then the new blocks, I have created a plethora of blocks. You probably can't see them all, but these are some of them: select block, from block, join block, where block, etc. And each of these have subtle differences in the way that the block renders. What is the SQL output? What is the separator? So if I was to go into the select block, I've got a comma separator. So each of my columns are separated by a comma, and the output is always a select. And if I go into the from block, I've got a comma separator for multi-table from, whereas if I go into a join block, it's not doing anything because it is essentially the same as the standard new line. But for the time being, I just put a join block in. Okay, moving further down the class, we're going to have a look at some of the methods that are kind of just unique to select. And these are the group bys and having. And essentially what's happening here is we're allowing SQL and parameters to be supplied, and then we are adding a fragment to the group by block, and we're just creating a new SQL fragment with those parameters. And because it returns this add fragment, which returns this in itself, this allows, well, the method and group by and all of our methods for controlling SQL are chainable. So this means that we can chain and having and group by, etc., if we so wish. And we've just added in and select, added in our sequence, which is the important sequence, which is because we don't trust the associative array sometimes. And then we adding in the group by, which resets group by and then adds an and group by. Having does the same thing, so reset having and having. And then we've got or having. Select will reset our select block and then do an and select. So that allows us to completely reset our select statement. Sometimes that's useful. We'll come into that another time. And then we got some resets. Now basically everything in our traits, so all of these traits are essentially doing exactly the same thing, but they are just, whether it's a from method or a select method or a set method, it's all just building up fragments in our blocks. That's all they're doing. And so we can now test it out, see how it works. Right, so we're in the select statement test now. So we're going to ask ourselves, what are we going to test? What aren't we going to test? Does it work even? Okay, right, so of course it's going to work. Let's be positive. Right, so query, we're going to select from, let's just do user, right? And this is the chaining that I was talking about. So if I just do this, just so you can see it. So query, let's say where, let's just do like an account ID is equal to an ID, or a merchant ID, let's say, is equal to the same ID. Okay, let's put that in some brackets. And that needs to be an array, so it needs to be an ID. Notice that I'm not putting the colon in there. So it's just another little test we're going to do. And we're going to say and where, let's say the user's ID is equal to another ID, which we're going to put the ID colon in. So our named parameter, and that's going to be 2, right? So normally, I think in named parameters, this would cause a conflict. This is what I was talking about before. So we got an ID in one block using ID 1, and we've got another ID using ID 2 in another block. Right, so I'm just going to var dump out what on earth this query is doing. So to debug string. Okay, now this might be a bit small, so I might have to copy paste what it's actually doing. Okay, right. So the resulting string is this. Okay, so let's have a look and see what's going on. So by default, we're selecting a star in our select statement. So if I go in there, select star, I can overwrite that. Then we are selecting from user, which is outputting from user, where account ID equals 1 or merchant ID equals 1. So that's basically what this is doing. And notice that, again, just to let you guys know, we are using to debug string here. So we're just looking to see what it should look like, not what we would actually use in a parameterized query. If we were using parameterized queries, we would use get SQL. Okay, so let's just do that and output that as well, so we can see what the difference is. Okay, so the top one is our debug string, and the bottom one is what we would actually use in a query. So you can see that our IDs here, our named parameters, have been converted to query parameters, and this is how our block manager and our SQL modifier manages to get around this conflict. So we've got an ID here and an ID here, both of which are conflicting with each other, and yet somehow the code behind the scenes is figuring that out and saying, you know what, I know what you mean, and we're going to put those values in the right place. Okay, so let's just delete this output, and we're going to add some pretend logic. Okay, so pretend logic. If true, because this is normally what would happen, so you'd have some condition. Obviously, you wouldn't do if true, you'd have a proper condition, but we're just pretending, so this is what it might look like. And where, let's just say status, right? Here we're going to use a query parameter with a status of active. Let's just say, hypothetically, right, just so we can test out a string. And we're going to var dump our query to debug string again, just so we can see what it looks like. And let me just put this up top for you so you can see it. Okay, so rather than having to maintain a separate array and a separate string where we're concatenating our SQL, we're actually just able to build out our SQL in a nice, fluid way, even though we've got some pretend logic. And thankfully, it's applied our condition here, status equals active, onto our query. Now, once again, I'm using to debug string. If I was to use proper SQL parameterization, let's just do that. And whack that in there. You can see that we've got our proper query parameters that we would use for parameterized queries. Right, okay, well, I think that we've gone far enough. I'm losing my voice, excuse me. Yeah, I think we've gone far enough. In the next video, we're going to be looking at using the SQL Builder in a real-world environment, and we're going to be expanding it out into dedicated query objects, and we're going to be looking at a whole load of other things in the future as well, surrounding PDO, surrounding SQL, surrounding PHP. It's going to be epic. So make sure you stay tuned for that, and if you're not already subscribed, please do, even though I'm losing my voice and it's not very professional, but there you go. Right, I've got a cold. See you later, guys. Bye-bye.